Johnny gets on a Ferris wheel, which has a radius of 25 meters. Seem appropriate?
Yeah.
Sure, why not? And the center is 30 meters off the ground. Does that seem appropriate? What if it was 20 meters off the ground? Would you question the guy who wrote the question? Yeah. Unless it's actually a depression. Could work, could work. 2 complete revolutions take 180 seconds. Seem reasonable? You wouldn't want this thing going too fast, would you? Because there's children and elderly on it. And he gets on the Ferris wheel at the bottom. Does that seem appropriate? Well, some kids thought we would get on it like, halfway up or at the top. I haven't seen one that does that. Graph it. Sinusoidal. Which one's that? Yeah, either or. We haven't done tangent yet, or secant or cosecant, but there's always tomorrow. And do some other stuff. Well, let's graph it first. Okay, this is helpful, people. There's your Ferris wheel. Because where do we want to start these things? Well, when we got one that you know the equation of and it says graph, at least I've told you, what do you want to start with? What do you want to start with? Well, I put in numbers for all the other letters, so let's put in something there. Yeah. What is that? That's our midpoint. I know the amplitude is 4 units above that, 3, and it goes down to 4 units below that. That's kind of where I want to start this thing. So there's my Ferris wheel. I know I get on the bottom. I know this is 5. I know that is 25. Therefore, that is 25. As I'm on it, I'm going to do periodic motion. I'll show you a graphic of that in a sec. Okay, where's my midpoint? Right there. Right? That's what I want to do first. What is this number? Yeah, 5 and 25. That's where I want to start. I want to put that line there. There's -5, 0, 5, 10, 20, 30. That's pretty good. I like that. I'm getting better. Then what did we start with? Once you know that, then we look at the amplitude. From this midpoint, what's my maximum? That's not good. How high does it go? 25 above this point, which goes up to 55. How low does it go? 25 below that point, which is 5 off the ground. Okay? So 5 is there. That's the lowest point while I'm on this ride. Makes sense? And there's 60. Well, that's nice. So there's 55. That's my max. That's my min. Is my amplitude 25 in both places? If it's not, you fix it now before you do anything else. Okay? So, what else do I know? I get on at the bottom. 2 revolutions is 180 seconds. Okay, so I get on here and then I go around and I go around again, and that's 180. But what do I probably want to take out of that? I want to graph. Does it say graph 2? 2 complete. It doesn't say graph 2, so I'm just going to graph 1. I know at time 0, I go all the way around, and then at 90 seconds, I get to the bottom again, right? That's 1 full, what's the word? Revolution, but when I'm graphing sinusoidal functions, it's a period. Okay, so I'm going to go, well, it actually does go to 180, so I guess I'm going to graph 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, what? 21, 2, 3, 4, 5, 6, 7, 8, 9, 30, what? 1, 2, 3, 4, 5. There's 36 from there to there. What does that mean? Huh? Yeah, every second one, if I divide that in half, that's 18. Oh, looky there. There's a 5. 5, that's 10, right? 20, 30, 40, 50, 60, 70, 80. There's 90. That's halfway. Important point. Because what do I know? That's one period. But where do I start? He gets on at the bottom. It doesn't say that's when the stopwatch goes click and we start at 0, but you must take that away from that. That's what it implies. At time 0, I'm there at the bottom. And one full period later, I'm back there again. And then another period later, 2 full revolutions, I'm back there again. Okay? So guess what happens halfway between 0 and 90? Well, let's look at our picture. 0 is there, 90 is all around. I get to the top. Does that look like 180 degrees past 0? What's half of 90? 45 seconds. At 45 seconds, I got a maximum. That's when I'm at the top. And 45 seconds after 90, can I visualize this? Is that the halfway one? I'm also at the top. I better check. 100, 110, 120, 135. Okay? Are we getting pretty familiar with these sine functions? What happens halfway between the minimum and a maximum? I don't care if it's a cosine or a sine. Yeah, that's the midpoint here, okay? My vertical displacement. So that is what? 45? So what's half of 45? 22 and a half. There's 20. There's 25. There's 22 and a half. Halfway between here and here. Well, let's count squares. 1, 2, 3, that's 4.5 squares. 1, 2, 3, 4.5 squares. That's another 22.5 seconds. Now I can graph this thing, and we're going to do this, right, people? We're going to do that. Okay, and 1, 2, 3, 4.5 squares is there. And 1, 2, 3, 4.5 squares is there. Nice and round. But missed it. Good enough. Cool, eh? Well, if you just have a little patience, I will tell you. I wouldn't show you something, then just get away. You can see that. Okay? Just wait. You see people writing? You're not, of course, because you never do, but other people are jotting some stuff down, so you're just going to have to wait a second. Okay. Hey, does that look like a Ferris wheel? What else does it look like? That's right, Alicia, a unit circle. Very good. Let's see what a sine looks like. As I go around this unit circle, as this degree gets bigger, as time goes on, maybe that can be a kind of a periodic function. And move. Move. There's other chairs here. It's not important either, Lewis. Don't worry about it. Almost at 180 degrees. Do I get another 0 for sine? Yeah, right? This is my, see my output, see my opposite, getting bigger and bigger, there at 0, there at 0. See that red opposite? See how big it's getting? It's getting to be a maximum right about there. The opposite side is maximum. You're right, negative maximum. Okay, yeah, you're right. 1 full period of a sine wave. Cosine. Yes, I'll show you both in a sec. I'm feeling deprived. The x-coordinate. Remember, it starts at a maximum, 1, and then gets smaller and smaller and smaller until it's 0. Then it gets bigger in the negative direction until it's -1. Okay? That's you going around the Ferris wheel. And this is someone plotting this versus time. That's probably how fast it goes too. Wish it was a little quicker, but I can't speed it up. Right? And then, well, actually, coming up, this is where you get on the Ferris wheel, right? At the minimum. That's where you get on at the bottom. So that's where that thing is grappling from. And yeah, I can put them both on there. Exactly the same shape. One's just out of phase by the other one by about that much, 90 degrees. Okay? That's what'll happen. So, there it is. What is the equation for this graph? Not that. Right, a sinusoidal function. Now, who likes sine? All right, sine it is. What's my amplitude? From here to here is 25. Sine, what's my period? 2 pi over 90. Sine starts here. How far away is that from 0? What's my phase shift here? Yeah, what was half of 45? 22.5. Do I want to add that or subtract it? It's moved to the right from 0, so that's a minus. And how far is this guy from 0? What's my vertical displacement? Okay. Who would prefer cosine? It is, if this thing started right there and went like that, that is a natural cosine. No phase shift at all, right? What's the relationship between this and that? It's just reflected over this line. It's a negative cosine. So amplitude is the same. Negative takes care of that. Period doesn't change. That's the same. What's my phase shift? It's not there at all. So I can put -0 or just don't put anything. There's no phase shift here. Okay? I don't have to move it left or right. It starts right there, right at 0. It's just flipped, so it's a negative. Okay, so you don't have to write that. And does this change? No. Everything's the same. The only difference between sine and cosine is a phase shift. Everything else is the same. So I don't care which one you like. Just don't get really strange and creative. Okay? So I'm the guy who has to mark this thing. Okay? Predict Johnny's height at 152 seconds. This is a real life question. We never even said it, but this is time down here. What's the unit? Seconds. What's this? Height. In what unit? Meters. At 152 seconds, where's that? 100, 110, 20, 30, 40. About there. Any guesses as to what his height is? How could we be exact? Oh, you got technology? Did I tell you the story about when I was a boy? Which one do we want to use? Doesn't matter. Let's use cosine. Are you in radians? Two pi divided by 90. Okay, this one is nicer because there's no phase shift. Because how many brackets are you going to need here to put that one in? Just two. No. 2 halves, so 4. Yeah, 2 left, 2 right. All right. Okay, close the bracket. Plus 30. What's your window going to be? 0 to what? How about 180? X goes from what to what? 55. Let's go to 0. Whoa, hey, that doesn't look like nothing. I forgot an X, didn't I? That's just a number. 2 pi over 90. Got to have a variable in there. There we go. Does that look like the blue line? Yes, it does look like the blue line. Trace. I want what? 152, sister. 152. Is that X or Y? Do you want to hold that trace button until it gets 152? Or do you just want to go 152? Exactly to the hundredths, that will tell me the height at 152 seconds. 39 point, you know, everything else. 39.4, okay? Meters.
Would that be answering the question though? This is predict.
That's a pretty good prediction. Oh, who's not going to pull this out and check that answer, okay? Like, am I going to say predict? Yeah, 30. Well, you said predict. You didn't. That's my opinion. What's a better color, red or blue? Huh? Come on, it's no right, no wrong. No, obviously I'm teaching you how to do this with a calculator, right? Okay? Any questions on C? Remember how I did that?
Yeah.
Reese? Yeah, absolutely. You bet. You can do it the long way. You put 152 right in there, you're going to get the same thing. Okay? D. What's the first time Johnny's 20 meters off the ground? Because remember, Johnny is going to be 20 meters off the ground twice every 90 seconds. So there's an infinite amount of answers. He's first off the ground. Let me get rid of that mess. Right about there. Whoop, did I do that? No, I didn't. I'm looking at the time, not the distance. 20 meters, there's 5, 10, 20, right there. Close, but no cigar. Looks like about 16, 17 seconds. Okay, how do I do that on here? I could trace. That's way over there. That's going to take me a long time. I want... Can you let me tell you instead of guessing? I want to put in y20. Yeah. Uh-huh. Then I can do an intersection. Or if you think you got it dialed down, what was our guess? About 16 seconds? We'll put in 16. Let's see what it looks like. Needs to be bigger than 16. Let's try 17. Oh, too big. 16.5. That'll work too. Okay. 16.7. Ooh, too big. 16.65. 16.62. Okay. Or just take an intersection. That's pretty darn close to that point. 16 point, I don't know, 62. It depends if it says tenths or hundredths. If it says hundredths, you probably want to do intersection. Okay? Any other questions? Got one more. Tides at Tofino is, on a certain day, 60 centimeters. This occurs at 1 a.m. That's a big graph. I got to make this smaller. Maybe even smaller. So we go to 20. Is each one of these 1, do you think? That would be nice. That's 0 a.m. That's 1 a.m. 2 a.m. 3, 4, 5, 6, 7, 8, 9, 10, 11 a.m. 12 a.m. 13 a.m. Yeah, it's p.m. I know. Okay. Do you go to 12 and then go to 1 again? Or do you do the 24-hour clock? Because if you do that, you don't have to write a.m. or p.m., do you?
No, but there's also 24 hours.
That's true. Okay, I don't care what you do, but you got to make it right. Okay, at 1 a.m. it's at 60. Is each one of these 10, do you think? 10, 20, 30, 40, 50. Hey, that's nice. That's when the tide is the highest. The low tide is 10 centimeters at 8 a.m. 4, 5, 6, 7, 8 a.m. it's at 10. Guess what we got to do? Graph that, find an equation. That's the max. That's the min. Because it tells you. Low tide is another way of saying minimum. Okay? So, 10, that's 60. How far is it from there to there? 1, 2, 3, 4, there's 5. So 2.5 is the midway point. It's not pretty, but that's where it is. Okay? I know halfway in between this point and that point, between 1 and 8, is going to be where this thing crosses, right there. 3.5. So 1, 2, 3.5 is also where it's going to cross there. And how far is it from here to here? 1 to 8 is 7, so if I go another 7 and get to 15, that is 1 complete period, which is kind of valuable information, isn't it? Cosine or sine? Yeah, this one's kind of obvious, right? So, what's this? What's my displacement? What's my amplitude? 10, 20, 30, halfway between 30 and 40, that's 35. What's my amplitude from here to there? $35 to 60 is, yeah, kind of, didn't we have that before? 25, I want to use a cosine. What's my period? From 1 to 15 is 14. And again, you can bracket that if you want. You don't really need it. I think it's an X. I used a Y anyway, so whatever. It might be a T. What's my phase shift? 1 unit to the right. And, oh, I can't write over there, darn it. I gotta move that. My displacement, how far is that dashed line above 0? 35. Okay. Is it? Almost looks like a tide. You know where the biggest tides in the world are? I don't think so. Isn't it in Nova Scotia? Fanny Bay?
I was just
Huge, unbelievably high from max to min.